Right now, you are not as real as you think you are. Look around you, your phone, your hands, the air, the ground beneath your feet. All of this feels solid, predictable, normal, but it isn't. Underneath everything you see, reality is doing something very strange. So strange that even the people who discovered it didn't believe it. They argued about it. They fought over it. Some of them hated it. And yet, every piece of modern technology you use exists because of it. This is the story of quantum physics, the science of the very small, the science that broke reality, and somehow still works. For most of human history, physics made sense. Things moved when pushed. Things stopped when friction slowed them down. Cause led to effect. This worked perfectly, until scientists tried to look closer, much closer. When we zoomed in, past cells, past molecules, past atoms, reality stopped behaving. Light didn't act like light anymore. Matter didn't act like matter anymore. And certainty disappeared. Classical physics failed, so we invented a new rulebook. That rulebook is quantum physics.
Everything is made of atoms. Atoms were once thought to be tiny solid balls. They are not. Atoms are mostly empty space. At the center is a nucleus. Around it are electrons. But here's the problem. Electrons don't orbit like planets. They don't have neat paths. They don't have fixed positions. Instead, they exist as possibilities. This is the first big idea of quantum physics. At the smallest scales, things don't have exact locations. They have probabilities. Let's talk about light. Light was once thought to be a wave, like water, like sound. Then experiments showed it behaves like particles, tiny packets of energy. So which is it? A wave or a particle? The answer is both. Light behaves like a wave and a particle. Not sometimes, always. And it gets worse. Electrons do this too. Matter itself behaves like waves. That means objects don't just exist. They spread out. They interfere with themselves. They blur into possibilities. Reality, at its core, is fuzzy. This experiment changed everything. You take a wall with two tiny slits. You fire particles at it. If particles are solid things, they should make two piles behind the slits. They don't. They form a wave pattern, as if each particle goes through both slits at once. Even stranger, if you watch which slit the particle goes through, the wave pattern disappears. Just by observing, you change reality. This is not philosophy. This is experimental fact. Measurement changes outcomes. In the quantum world, things don't pick one state. They exist in many states at once. This is called superposition. An electron can be here and there, spinning up and down, present and absent. Only when you measure it does it choose. Until then, it's all possibilities. Reality doesn't decide until it has to. To show how absurd this sounded, a physicist invented a thought experiment. A cat in a box, a quantum trigger, a poison. Until you open the box, the cat is both alive and dead. The point wasn't that cats are magic. The point was this: quantum rules apply to small things, but when do they stop applying? Where does reality collapse into certainty? No one fully agrees, and that's unsettling. Here's another uncomfortable truth. You cannot know everything about a particle. You can know its position or its speed, but not both perfectly. This isn't about bad instruments. This is reality itself. The universe does not allow perfect knowledge. Uncertainty is fundamental, not a bug, a feature. Now comes the strangest part. Two particles can become linked, not connected by strings, not signals, linked by state. Measure one and the other instantly knows, no matter the distance. Across a room, across a planet, across the universe. This bothered even Einstein. He called it spooky action at a distance, but it's real and it works. Reality is not local.
Particles aren't really tiny objects, they're ripples in fields. Every type of particle has its own field filling all space. An electron is just a vibration. A photon is just a vibration. Matter is energy, shaking in different ways. You are a pattern, a stable vibration in a cosmic field. You feel solid, but you're not. Atoms don't touch, they repel. Electrons push against each other. Your hand doesn't hit the table. The forces stop it. Solidity is an illusion, a very convincing one. This isn't abstract. Quantum physics powers computers, phones, GPS, lasers, medical scanners, the internet. Without quantum rules, none of this exists. Your modern world is built on uncertainty. Your brain evolved for rocks and trees, not atoms. Quantum physics violates intuition because intuition was never meant for it. Reality is not obligated to feel comfortable. It only has to work. This is where things get controversial. Does observation require a conscious observer, or just interaction? Physicists argue about this. Some interpretations say reality collapses when measured. Others say all possibilities continue forever. Multiple universes, infinite branches, every choice creating new worlds. We don't know which is true. That's the honest answer. Let's be clear, quantum physics does not mean thoughts control reality, you can manifest anything, consciousness creates the universe. It's strange, but it's not magic. It has rules, very strict ones. Quantum physics tells us something profound. Reality is not fixed, not fully determined. The universe is not a machine ticking forward. It's a cloud of possibilities, and we live inside it. Every moment is a collapse, from potential to experience. Quantum physics doesn't tell us everything, but it tells us this: the universe is deeper than it looks, stranger than it feels, and far more mysterious than we expected. At the smallest scale, reality is not solid, not certain, not simple, and yet, here we are, patterns of energy, thinking about the universe, trying to understand itself. That might be the strangest thing of all. If this video made you feel a little uncomfortable, that's the point. That feeling is what happens when certainty starts to crack, when you realize reality isn't as solid as it looks, and that beneath everything familiar, there's uncertainty and possibility. And this is only the beginning, because quantum physics connects to much bigger questions about consciousness, about time, about whether reality exists on its own or depends on observation. If you want more videos that explore the strange edges of science and reality, make sure you subscribe. And if this video made you question something you've always taken for granted, let me know in the comments. Thank you for watching. And remember, reality doesn't have to make sense to be real.